So we have been given a data set, and now we are going to use those information to find 5 number summary, which is maximum, minimum, quartile 1, quartile 2, and quartile 3. So first of all, we will put the numbers from the least to the greatest so that we can able to find 5 number summary. After we finish, the first thing is that we have to find the middle number, okay, which is 24, and that will be quartile 2. And then looking at the lower side too, we have to find the middle in that lower side, and that will be quartile 1. And then looking at that, which is the right hand side, that's going to be the upper side. We find the middle number, and that's going to be Q3. Then whatever from the beginning, the least number is the minimum, and the greatest number will be the maximum. So we're going to put this on the number line to create our box plot. So we draw the line and look at the numbers so that you can choose your scale. So here we are going to go by 5, 5. So 0, 5, 10, 15, 20, 25. So we keep on going until we get 26. Everything have to be included in there. And 55 and then 60. So we are going to put the box plot. So first of all, we get the minimum, we put a dot, and then the quartile 1 is going to be the box. So we put a line, and then we get our quartile 2 and quartile 3. Draw a vertical line, join it together to form the box. Then the maximum. Now we're going to join the minimum and the maximum together to form the whiskers. That's going to be the whiskers. Okay, so now we have our box plot. You want us to find the range. Range is maximum minus minimum. So be careful with that. Don't use the number on the number line, but the actual value that you got. So 56 minus 7. That will give us 14. Then the interquartile range, which is IQR, is going to be quartile 3 minus quartile 1. 53 minus 21 give us 12. Then the outlier. So we're going to find the base of the outlier, which is 1.5 times the interquartile range, which is 150% times the interquartile range. So any number that is outside of this will be considered to be an outlier. Okay. So we got the interquartile to be 12, so we multiply, and then we got that. So now we are checking the lower side and the upper side to see if there is an outlier. Okay. So that's going to be Q1 minus the outlier base that we calculated. So it's going to be 21 minus the 12. And that gives us 3, and we put it in there. So any number beyond that will be an outlier. But here we see that there was no number, the given data, there was no number beyond that. So there's no outlier on the lower side. We have to check the upper side to see if there's an outlier over there. It's going to be quartile 3 plus the 1.5 times the interquartile range, which is the outlier base. And we got 51, so we put it in there. So we see that the downward sky was beyond that point. So any number beyond that one will be an outlier, which happens to be 56. Okay, so this one happens to be an appointment that they go to hospital. So you could see that we can't say that the 56 will be an outlier. We have to be able to describe the distribution shape. So look at the middle. Most of it is on the right hand side. So on the right hand side will be positively skewed or right skewed. We have to be able to make a conclusion here. This was a patient is going to see their doctor. So we could see that 50% of the patient wait 24 minutes. So we could see that. And the maximum time, which is 56, considered to be long delay. It was an outlier. So that person was unduly delayed. Thank you.